Here with the logic gates, remember that you have these three basic gates. And for you to draw a logic circuit, you can just use these three basic gates and you will be able to solve these problems, right? So you have the AND gate, the OR gate, and the inverter. The purpose of the AND gate is like a multiplication, right? So remember the AND gate, you take whatever is here and here, then it's like you multiply it, right? With you can put a dot here if you want, but this is basically just AB. And then with the OR gate, it's like you add it, right? So it's AB, it's actually A or B, right? But the OR sign is this plus sign. So it's like you add. So if you're going to get, remember this A and B, they're just variables. A variable is just a placeholder in memory. They just create memory if you're programming. It's just a placeholder like name, surname, age. Remember, those things can be different per person, right? So A is the same. So you might get ABC. And then here you get ABC. So now you're going to get ABC plus ABC. But in digital terms, we say ABC or ABC. Whatever is here, this input here, you OR it with this input here. That's what it means. And then inverter, whatever you pass here, you invert it. Everything that's an input here. Remember, A is just a variable. It can hold anything. It can hold A, B, C, D, E, F, G. You get my point. It can hold whatever it holds. Then whatever passes, after it passes here, you need to invert everything, the whole of this input. So it will be not A, B, C, D, E, F, G, right? So we're gonna look for a nice example. So the most important thing is that you need to check how many inputs do you have. So for you to know how many inputs do you have, yeah, this was a nice example actually. For you to know how many, because we never do with an E, right? With an E, we never do with an E. So again, let me just mention that in one of the exams in the past, there was an E. Remember, you have for a Cardinal map, you have 4 variables, right? 4 variables. Now imagine if here there's an E, right? You won't be able to draw a 4 variable Cardinal map, but that was a printing mistake. That E just needed to be erased. You understand? If it happens in future, it hasn't happened again, but it has happened in the past, right? So that E was here, you just had to erase it. Okay, let's go back here. So now for here, because they didn't put the number of variables in here in brackets, you need to figure it yourself. How many variables do you have? Okay, we know we have A, we have B, we have C, but now there's a D, okay? We have D, we have E as well, okay? A is already there, B is already there, E is already there. So we have 5 variables here. So that's why all our inputs, they come this side. A, you make, when you're using a breadboard, for example, that's where you build this digital circuits, right? If you're still in school, it's with a breadboard. So in that breadboard, you conduct, this is basically a conductor. You put your conductor here, your conductor here, conductor here. It can just be a piece of wire, anything that can conduct your 5 volts. It's 5 volts, right, of electricity. Here, 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 here. So this is your input A, input B, input C, input D, input E. So to solve this one, remember our 3 basic gates. The one that multiplies is an AND gate. So an AND gate, in this case, it has how many inputs? 1, 2, 3. The one that multiplies is an AND gate. So we take these 3 inputs, we connect. We have our 3 inputs here, right? With these 3 inputs, we are done. We can leave it up until here. Let's go to the next one. The next one, it's DE. DE, we can see what gate is that? It's an AND gate as well, right? With an input D here and an input E here, right? But that DE wants to be inverted. So it means this output of DE here is gonna be an input here, right? Remember, A is just a variable. So DE is gonna be here, and then when it comes out, it will be DE naught, right? So we go and conduct. So we make a point here. So please make this point here just to be professional. And then for D, and then another point here to conduct on E. Then we take it to a 2-input AND gate. Now we have DE. DE, AB, DE is the same. Now we want to complement everything. Then we just put an inverter here. Then you have DE not. Those who understand this better, they can just put a NAND gate here. This and this is the same as a NAND gate. But even if you did it like this, you will get 100%. You will get 100%. But if you are working, the purpose for them to do this, they want you to save the number of gates that you're going to use, right? So now, instead of buying an AND gate and then an inverter, you can just buy a simple NAND gate. You can put the NAND gate here, it will give you the same. That's if you are doing practicals now, if you are working, right? But for the purpose of this module, DE, you put another inverter here, you can do it like this. Not to, just to keep using 3 gates if you want. But if you really understand, yes, you can use the NAND gate here. Okay, then here, let's come here. So here we have 3 inputs. We have A, B, E, but this A is complemented. So before we do anything, we're going to invert the A. So we take the H, then we invert it, right? Then we have not A. Now, not A, B, E, it goes into a AND gate. This AND gate has got 3 inputs, right? So the first input is not A, second input is B, the third input is E. This together, they make not A, B, E. It is not A, B, E. Then everything else, this is sum of product. This is SOP for sum of products. These are products, we are adding them. So we're getting the sum of products. So remember, a sum is a result of addition. So that's why we are adding these products together. So we have ABC. We need to OR it. Which gate adds is the OR gate. We need to OR it with this DE naught. Yes, DE naught. We're going to OR it with that. And then also with A naught BC, not A, BC, right? So it's a 3 input. How many inputs do we have? 1, 2, 3. 3 input OR gate. It gives us the output. In this case, it's called X. In most cases, it's called F, right? In your question paper, you will see when we look for another example, it's called F. Okay, so you see here's one already that was saying F. So let's see maybe from a question paper how much, for how many marks is such a question. Let's leave that one. Let's check here. Exam. Maybe exam prep 3, exam prep 2. Let's check exam prep 2. Okay. This is Boolean algebra. 2's complement, Boolean algebra. Let's go for, okay, it's fine. Let's go for this one. Great stuff. Implement the logic circuit. So we found this one, but it's not, but you see this one is just because it's three variables. It's normally around 12 marks, but let's do this one because it's a bit different. So like I said, in most cases, your output will be F, right? And then your inputs will be X, Y, Z when you're dealing with this. So let's do this one quickly. Okay. So here we check. The first thing that I said we must check is the number of inputs that we have. We know we have X. 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 Then we have Y. X, Y. Then we have Z. But now we have W. Okay. So according to what is it? This order, it's W, X, Y, Z, right? So we can put W here. So we have X, Y, Z, W. Y is already there, Z already there, X, Y, Z. Okay, great stuff. This B, guys, is not part of this, please. Okay, so we have 4 inputs and our output is F. So we're going to draw the straight lines for our conductors. Please just give me a minute. Okay, guys, I'm back. So we're basically going to make a conductor for Z. We're going to make a conductor for Z and then another conductor for Y, then X, then W, right? So we're going to start with this one. So remember our 3 basic gates. It's the OR gate, it's the AND gate, and it's the inverter. So if any variable has got a complement, we know that we need to use the inverter. So we're going to start with this one. So this gate has got not X or not Y or Z. So it's a 3 input OR gate. But before that, let's eliminate this. Let's solve this problem first. So we need not X. We're going to conduct it there. Not X with an inverter. Then not Y. Not Y with an inverter. All right, now we have a 3 input OR gate, right? So that OR gate has X, Y, Z. So we need Z as well here. Into a 3 input OR gate. Here's our 3 input OR gate. So it will give us this, right? Not X, not Y, and Z. It will give us this. So then we go here. W, Y, W, or Y, or not Z. So let's start with not Z. Not Z, we're going to invert it. Not Z, we invert it. Come on, I know. WY, then we need W, going to conduct W, then Y, into a 3 input OR gate, right? Now we are here. So we have X, Y not, Z. So this one, because I know you guys are following, so we can just follow the order now. So we're gonna start with is it X? Let's see. X. So we're gonna take X. Then we're going to take Y, but it's inverted. So we somewhere just gonna put the inverter. This is Y. Going to conduct it by the input Y. This is our inverter. So we have X, not Y. X, not Y, Z. So we take Z as it is. So we're going to conduct here. Here's our 3-input OR gate. Great stuff. So now it means this terms, this one, this is basically in POS, right? Product of sum format. So the only difference is that it means this is ended with this and it's ended with this. So this is a 3-input AND gate, 3-input AND gate, right? So this 3-input AND gate, go here, here, and here. Then you can put the AND gate with your 3 inputs. Then you are basically done. So this will be your output F. Then you guys can write this. For example, you can write this, you can write it here. This, you can write it here. This, you can just write it here. But here's your output. Any questions here? Let me stop the recording. All right. Thank you, thank you, thank you. Since you are the